Hello.
Good afternoon, sir.
Good afternoon. How are you?
Fine. Sir, my voice is clear, right?
Yeah.
Okay.
Is my voice clear?
Yes.
So we have discussed this till PN junction diode. I told you, and after the PN junction diode, now we will discuss the reverse forward biasing and reverse biasing of the PN junction diode. So what is the means how this is diode na PN
Yes,
junction diode symbol C
yes.
symbol once again like this and like this. Okay.
Yeah.
This we will connect with a battery.
Yeah.
Okay. And when the positive terminal of the battery is connected to P side and negative terminal of the battery is connected to N side, I will show you also. Then this diode will be considered as the forward bias. Forward bias means in this case current will be more. In case of the reverse biasing, the current is very less. Okay, the current is very less. Okay. So forward biasing very simple. Forward biasing or in forward biasing. Okay. So in forward biasing, this is your diode, PN junction diode. This is the PN junction diode.
Yes, sir.
And this is P side. This is N side.
Yeah.
And this PN junction diode is battery. This PN junction diode is connected with a battery.
So your voice is lying, sir.
Yeah. I know. Okay. Now it's okay.
Yes, sir.
Okay. So here, this is the PN junction diode. Okay. And in negative and positive, I am just removing it.
Okay.
So, okay, now focus on this diode, and this diode is connected to this battery.
Yeah.
So this is the positive end of the battery, this is the negative end of the battery, and this is the rheostat. Rheostat means variable resistance. Okay.
Yeah.
So we can vary the resistance with the help of the
With
rheostat, and
yeah.
with the help of the rheostat, we can vary the resistance, and by changing the resistance, the potential difference across the terminal of the battery can be changed accordingly. This will be attached with the battery, you can say, in some manner. And this is the key. Okay, open key, close key. When closed, key will be closed, so current will flow.
Current
Key
flow.
will be
Yeah.
open.
Yeah.
Okay. So this positive end of the positive terminal of the battery is connected to P side,
Yes.
and negative end of the battery is connected to N side of the diode.
Yes.
This is P side. This is N side. So this diode is known as the forward bias.
Okay.
Forward biasing. Okay. One more thing. Here, in case of the forward biasing, I told you now the concept of the potential barrier.
Yeah. Yes.
Potential barrier, na?
Yeah.
Here I told you, I think here. Due to the depletion layer, due to these negative and positive ion, a potential difference created across the depletion layer, and that potential difference is known as the potential barrier.
Yes.
So basically, in case of the forward biasing, what will happen? The potential of this battery, suppose, will be in this direction, positive to negative.
Yeah.
Positive to negative. Because electric field is always positive to negative, so we can take this side. This side as this is the direction of the potential. Potential is directionless quantity. Potential is what? Potential is just a scalar quantity. So we cannot talk about the direction. But we are just taking here that potential is increasing in this side. Positive to negative. Okay. Now, here, this PN junction diode, this is the P side, na? So P side is negative. Means on P side, there will be the negative potential.
Yes.
This is negative and this is positive. And the reason is that I told you in the last class, this is the P side. This half is P side and this half is N side.
Yeah.
So On P side, negative charge is there, negative
Yeah.
immovable ions are there. On
Yeah.
positive side, positive immovable ions are there.
Yes, sir.
So how I shown the diode? This is negative and this is positive. Okay. So P side negative,
Yeah.
N side positive.
Positive.
Okay. So direction of the potential we have taken from positive to negative. So this is positive potential to negative potential. So in this direction, we can take the direction of the potential difference. Okay. So both are in opposite direction.
Hmm.
Again, I am saying this is a scalar quantity. Direction is not significant. But
Okay.
we want the net voltage, so that is what I am telling in this way. Okay. So the net potential difference, both are in opposite direction. So you can say this is the applied voltage minus the potential barrier. VV is the what is the voltage across the diode? Uh, VV means the
Yeah.
potential barrier. So V
Yeah.
minus VV, this will be the potential barrier. Means the
Mhm.
potential barrier will decrease. Potential barrier will decrease. Earlier, this is the potential barrier VV.
Yeah.
Now there is some value which is subtracting from this VV, means that value, the resulting value will be less, means that value is that. So this value is reduced value as compared to this VV. So you can say the
Yeah.
potential barrier will decrease in case of the forward biasing. And
Yeah.
when the potential barrier will decrease, what will happen? More flow of the charge carrier will take place.
Yeah.
Okay.
Hmm.
From P side to N side, hole will move. From N side to P side, electrons will move.
Yeah.
So due to that, what will happen? Recombination of immobile ions and holes, recombination of electrons and positively charged ion will take place. Thickness of the depletion layer will decrease.
Yeah.
Thickness of the depletion layer will decrease. Resistance will decrease. Resistance will decrease. Current will increase in the diode. More
Yeah.
current will pass through the diode. So
Yes.
basically, this theory is written here. So
Okay.
one by one, we will discuss that. So the PN junction is said to be reverse biasing, forward biasing.
Right? Yeah.
Yeah, forward. If positive terminal of the battery is connected to P side and negative terminal is connected to N side. Okay. The potential barrier V minus VV decreases across the junction.
Yeah. Yeah.
And hence energy barrier decreases. So but this potential is what? Potential is, you can say, a form of energy, you can say. Means
Okay.
not a form of energy. Potential is something which is related to energy.
Okay.
So if the potential will decrease, then energy will also decrease. So the potential barrier decreases across the junction, hence energy barrier decreases. Energy barrier decreases. Okay. So
Okay.
majority charge carrier can flow across the junction. Resistance across the junction decreases due to the diffusion of electron. I told you the meaning of the diffusion and drift.
Yeah.
I told you not what is the diffusion and what is drift. So diffusion is when take the N side. N side, electrons are majority charge carrier.
Yeah.
So try to imagine the picture
Yeah.
of PN junction diode. So here
Yeah.
are the electrons.
Yeah.
So when the electron will cross this junction, this
Yes.
is the junction now. When the
Yeah.
electron will cross this junction, means we will say electron is diffused. When this hole will cross the junction, we will say hole is diffused. Diffusing means crossing the junction.
Okay.
And drifting means when the electron is moving from here to here to here to till the junction. That is known as the
Okay.
drifting. So due to diffusion of electrons and holes, means electrons and holes are crossing or moving. Okay, holes are moving like this, electrons are moving like this.
Yeah.
Across the junction, the width of the depletion layer decreases. So the reason is that, again you can see, when this hole when move to N side,
Yeah.
so this will recombine. Some of the hole will recombine with negative charge because holes is positively charged. So
Yeah.
recombination will take place, and what will happen? The thickness of this depletion layer will decreases.
Decrease. Yeah.
And from here the electron, from here when the electron will move, electron will recombine with the
Yeah.
positive ion.
Hmm.
So again, the depletion layer thickness will decrease. Okay.
Okay.
So holes across junction, width of the depletion layer decreases. As a majority charge carrier flow across the junction, majority charge carrier flows across the junction, electrons and holes. Electrons are the majority charge carrier in N side,
Yeah.
holes are the majority charge carrier in
Okay.
P side, and
P
both
side.
are now moving. Okay. Hence,
Yeah.
current is in microampere. Current is in microampere.
Okay.
So microampere current will be there. A current of microampere will be there. So this is the graph of the potential barrier across the junction. How the potential barrier across the junction will change. So when the diode is in the normal condition, this is
Yeah.
the condition when the potential difference across the diodes is constant.
Yeah.
Okay, when you will move uh, from junction, means here to here, when you will move, the potential difference will be almost same. When you will just crossing the junction,
Yeah.
when you are just crossing the junction means you are moving from negative potential to the positive potential. So
Yes.
potential difference will be increased. Potential difference will increase.
Okay. Yeah.
And after that, the potential difference again become constant when you will move to this side. So constant, suddenly increasing, and then again become constant.
Yes.
So this is the potential graph, potential difference graph before forward vising. Before forward vising, okay, before forward vising, this is the graph, and this value is the potential. This value is the value of the potential barrier.
Okay.
Now, after the forward vising of the diode, this is the graph.
Okay.
You can write after forward vising. So after forward vising, the potential barrier will become this constant, suddenly increase, and this graph will be little bit lower. So V minus VV will be the new potential barrier, and that is decreased as compared to the previous.
Yeah.
So what you have to remember in forward vising, positive terminal of the battery is connected to P side,
Yeah.
and negative terminal of the battery is
N
connected
side.
to N side. Okay. And potential barrier will decrease, more current will be there.
Yeah.
In case of the reverse vising, positive terminal is connected to N side.
In reverse vising?
In
Yeah.
reverse, what is happening in the forward vising? Positive terminal we are connected to, connecting to P side, but in case of the reverse vising, it will be reverse of the connection.
Yeah.
You can say
Yeah.
positive terminal then will be connected to N side. So
Yeah.
in reverse vising, negative terminal, all things clear now. This is diode and this is rheostat.
Yeah.
Okay,
Yes.
this is a battery, this is a key. Okay.
Yeah.
So now you can see negative terminal is connected to P side now, and
side.
positive terminal is connected
N
to
side.
N side now. Now I told you we take the direction of potential difference positive to negative.
Yeah.
So this is the direction. Okay, this will be the applied voltage will be in this direction. And I told you one more thing. This N side is negative. N side is negative, na? Here we take it negative.
Yes.
Oh, sorry, N side is positive and this is negative. So this is the direction of the potential barrier. So potential barrier direction will remain same in this direction.
Okay.
Positive to negative. So this is the direction of the potential barrier. Both will add it up. V plus VV. This is the potential barrier. Now potential barrier is it increasing or decreasing?
It's increasing.
It's increasing. So when the potential barrier will increasing means energy barrier will increasing means
the resistance will also increase.
Yeah, resistance will also increase, but before that we can say that the motion of the charge carrier will decrease.
Yeah.
And due to that the depletion layer thickness will increase, you can say.
Yeah.
Okay. Or the resistance will increase. Resistance here will increase.
Yeah.
and the current will be in the microampere or less than the forward biasing.
Okay.
So when positive terminal of the battery is connected to N side and negative terminal is connected to the P side, the PN junction is reversed by the potential barrier increases B plus BB and hence energy barrier increases. The majority charge carrier moves away from the junction and hence the depletion layer increases. Resistance across the junction increases. No current flows across the junction due to the majority charge carrier. So in this case, now what will happen? Due to the large potential barrier. So due to the large potential barrier, what happened? The majority charge carrier will not cross the junction or will not move towards the P means electrons will not move towards the P side and holes from P side will not move toward the
N side.
N side. They will move away from the junction. Okay. So when they will away from the junction means there will be no current.
Yeah.
There will be no current due to the majority charge carrier. The majority charge carrier move away from the junction and hence depletion layer increases. Okay. So no current flows across the junction due to the majority charge carrier, while there are some minority charge carrier which moves across the junction due to the temperature and hence current is in microampere. So the current, so there will be some very small current in case of the reverse biasing and that current is due to the minority charge carrier.
Yeah.
Okay, and that current will be in microampere.
Okay.
During the reverse biasing. So microampere, earlier in forward biasing, we have the current in milliampere.
Yeah.
In case of the reverse biasing, we have the current in the microampere. Now, this is very easy. Again, this is the graph before reverse biasing.
Yeah.
Before reverse biasing, what is the potential barrier? Okay. Again, we will draw it. This is the potential barrier, na?
Yeah.
This is the potential barrier.
Yeah.
Before I mentioned there also. VB is the potential barrier.
Yeah.
And after the reverse biasing, it will be
V plus VB.
V plus VB.
Yeah.
So this potential barrier here is increasing.
Yeah.
After reverse biasing. Okay. So this value is V plus VB. So this is the this is the reverse biasing.
Yes.
So what we learned from the reverse biasing? Negative end of the battery will be connected to P side.
P side.
And positive end of the N side potential barrier will increase.
Increase, yeah.
Resistance will increase.
Increase.
Depletion layer thickness will increase.
And current
will decrease.
Yeah.
And there will be some small current due to the minority charge carrier due to the temperature.
Temperature, yeah.
Now after that we will discuss the characteristics. We will draw the graph between the current and the potential difference in case of the reverse forward biasing and reverse biasing.
Okay.
VI characteristics. Just wait. I already written this somewhere. Where is one? So we will first discuss the VI characteristics of forward biasing of PN junction. So this is the forward biasing. PN junction diode is connected to the battery, and this is in the forward biasing condition.
Yes.
Okay. So what we will do now, when we will study the VI characteristics, means VI characteristics means we will draw the potential difference across the PN junction versus the current graph. So for that, there is a requirement of reading of that. So what we will do, for measuring the potential difference across this PN junction diode, we will connect a voltmeter, and we know that voltmeter is used to measure the potential difference, and it is always connected in parallel.
Yeah.
And here, with this PN junction diode, a milliammeter we will use, because this basically you can say it is an ammeter.
Yeah.
Ammeter. Okay. I am saying milliammeter because it will measure the current in milliampere.
Yeah.
Because in case of the forward biasing, I told you the current will be in the milliampere.
Yeah.
And ammeter is always connected in series. So here it is. Okay. And we know that the potential barrier will decrease, V minus VB.
Yeah.
Okay. V minus VB. And this V is the applied voltage.
Yeah.
Okay. V is the applied voltage. So basically this V is the potential difference across the PN junction diode, and this V is the applied voltage. Okay, this V is the applied voltage, and this is the V minus VB is basically the potential difference across the PN junction diode.
Okay.
So you should remember this. So this type of graph we will get something like that. This type of graph we will get. This is the current in forward biasing, and this is the voltage in the forward biasing.
Okay.
What voltage I am talking about? This voltage. Okay. Voltage across the PN junction diode. Voltage in forward biasing you can say, or voltage across PN junction diode. So it is the voltage across diode PN junction diode. So see this graph, this type of graph we are getting. First we will read the point A and A to B. First we will observe this graph from A to B. Now while moving from A to B, okay, the potential increases when you are plotting the graph now. Yeah. So what you will do, you will get some value of the potential at a particular value of the current, or you will get the particular value of the current at a particular value of the voltage. Basically you will get a particular value of current at a particular value of voltage, because you are changing the voltage so that the current is changing. Yes. So what will happen, suppose you have changed the voltage from 0 to this value. 0 to this value. Okay, so you have observed that in that case the current increases from A to B is very, very small current. Here current is 0. Initially the voltage is 0 across the PN junction diode, and current is also 0. But when you have increased little voltage, okay, when you have increased some voltage, the graph is like this. You will get the graph like this, and this graph is showing current is not increasing much initially. Now again you have increased the voltage from here to here. So again current is not increased. But when the graph, when the potential difference across the diode becomes 0.7 volt. This 0.7 volt is for silicon PN junction diode. Silicon PN junction diode. Okay. So it is written here now. Don't worry about that. So when here it will reach na. So when the potential, basically with the help of the rheostat, you are changing
the
applied voltage, and accordingly the voltage across the PN junction diode is changing.
Yeah.
So you have changed the applied voltage such that the voltage across the silicon PN junction diode becomes 0.7 electron volt.
Yeah.
Okay. In this case, what will happen? Now, where you have reached as 0.7 electron volt.
Yeah.
Now, when you will increase the voltage now from 0.7 volt, 0.7, 0.7 volt to little more. Okay,
Yeah.
when you will come from here to here, very little from here to here, you will see suddenly the current will increase. Suddenly.
Okay.
Suddenly the current is increasing. Huh? Okay.
So if we take 0.8 volt, then it
Yeah,
will
0.8 will be somewhere here, no?
Yeah.
0.7 is it? 0.8 you will take to current will increasing, na? Corresponding to
Yeah.
that, the current will be very, very large.
Yeah.
Okay. So 0.8 will be here. Suppose 0.8 is here. So what you will draw a perpendicular, and corresponding to this point you will check the current. So current will be large, na?
Yeah.
Okay. So now this is the theory written. Initially the current in the circuit is negligible. Initially the current is negligible.
Yes.
Okay. Till the voltage reaches the knee value or cut-in voltage. Basically, this value is known as the knee voltage.
Okay.
Knee voltage. Initially, the current is in the circuit is negligible. Initially, the current is in the circuit is negligible. See, from A to B and B to knee voltage, the current is less in the circuit.
Yes. Yeah.
Till the current reaches till the voltage across the PN junction diode reaches the knee value, or this is also known as the cut-in voltage. So this value, basically this is not volt, it will be electron volt.
Okay.
So this cut-in voltage or knee voltage for silicon is 0.7 electron volt. For germanium it is 0.3 electron volt. Okay. And the reason is that for germanium the knee voltage is less because the size of the germanium is more as compared to silicon. So the atomic arrangement in that is different. That is why the knee voltage is different. Okay. So before cut-in voltage, the depletion layer plays a dominant role in providing the barrier to the majority charge carrier. So before this voltage, what will happen? Try to connect all the things. Before the knee voltage, okay, the potential barrier will be large.
Yeah.
And the potential barrier will be large, so current will be small. But when you will reach the knee voltage, the potential barrier will be removed. Zero.
Okay. So cut-in voltage.
So before cut-in voltage, the depletion layer plays a dominant role in providing the barrier to the majority charge carrier. On reaching the knee voltage, the current increases exponentially. Even for a very small change in applied voltage at this stage, for the majority charge carrier, there will be negligible resistance at junction. So this I already told you what will happen when the potential barrier will decrease. But here, what will happen? The potential barrier will become zero.
Zero. Yeah.
Okay. That is why the current is increasing very sharply.
Yeah.
So this is the characteristics of the forward biasing. Now we will discuss the characteristics of the reverse biasing. So this is battery PN junction diode in reverse bias condition. So what we will do, we will connect a voltmeter across the PN junction diode, and micro ammeter we will place in series with the PN junction, because in reverse biasing we know that the current is in the microampere.
Yeah.
So again from here we will change the applied voltage, and accordingly the potential across the PN junction will change, and we will record that value, and corresponding to that value we will see what is the current, and we will plot the graph. So this type of graph we will
So your voice is lagging.
actually you should check. Is your internet okay?
I'll
You
check,
first
sir.
please check. Actually,
Yeah,
my
sir.
internet.
It's unstable, sir.
Yeah.
I think it's all right now.
Yeah. Okay. So basically, now in this case, to achieve the current, what we have to do? This is V plus VB. So the applied voltage, now we will apply the voltage, negative voltage we will apply. This V value should be negative. So we will increase the voltage in negative direction. Why we are doing this? Because we want to reduce this value to get the current.
Okay.
So here, the graph of this forward wise reverse vising will be like this. In the third quadrant, this graph will be plotted. So this is
Okay.
the current.
Yeah.
IR means current in the reverse wise. PR means voltage in the reverse wise. This is not the voltage in the reverse wise. PR is the voltage across PN junction. Okay. So this type of graph we will get from here to here. What you are doing here is zero voltage. From here to here, from here to this value. The current is very small. This value of current is small,
Yeah.
and this current is almost constant current.
Yeah.
Not changing. So this
Yes.
constant current is known as the reverse saturation current. So when the means you are increasing the voltage. Okay, you are increasing the voltage in the negative direction.
Yeah.
You are increasing the voltage in the negative direction, and there will be a point when the potential, this negative voltage, this negative voltage will become equal to the potential barrier. So this value will become zero, and at that point there will be the breakdown of the PN junction diode, and after that when you will increase the voltage, little voltage, after that you will increase, the current will increase very sharply. So when diode is connected in reverse bias, the current remains almost constant with biasing, and this current is called the reverse saturation current, and it is due to the flow of the thermally generated minority charge carriers, holes in p type and electrons in n type across the junction.
Okay.
When a reverse voltage reaches reverse voltage, see the word reverse voltage.
Yeah.
When a reverse voltage reaches a sufficient high value, the current increases rapidly, and this voltage is known as Zener breakdown voltage. So try to understand with the graph also.
Yeah.
Here zero voltage, and you are now increasing the voltage in the negative direction.
Yes.
Reverse voltage.
Yeah.
So what will happen? From here to here, the voltage is increased in the reverse direction. So this value will decrease, potential barrier will decrease.
Yeah.
And from here to here, there will be potential barrier. So due to that, the current will be almost constant. And when this breakdown voltage will achieve,
Yeah.
when this breakdown voltage will achieve, the current will increase sharply.
Yes.
Current will increase sharply. So when our reverse voltage reaches a sufficiently high value, the current increases rapidly, and this voltage is known as Zener breakdown voltage. As the value of this voltage is 1 to 2 volt to several thousand volt, it depends upon the doping concentration.
Okay.
It depends upon the doping concentration. Okay, so one more thing I want to tell you, the doping concentration. Effect of doping concentration on width of the depletion layer. So what will happen now? When you will increase the doping concentration, there will be more number of charge, majority charge carrier. If there will be
Okay.
more number of majority charge carrier, there will be, due to the diffusion
Yeah.
and drift, more will be the recombination of the ions and the charge carrier, and
Okay.
width of the depletion layer will increase. Hmm? Okay, and if the content concentration is decreased, so what will happen? Recombination will decrease and width of depletion layer will decrease. So
Decrease.
if
Yeah.
the concentration of the doping
Will
will
increase.
increase,
Yeah.
the recombination of electron will, with positive ions and holes with negative ion will increase. The width of depletion layer will decrease, and this is happening when you are increasing the concentration.
Concentration. Doping.
Hmm?
Yeah.
Hmm. Doping concentration.
Yeah.
Doping increase. You are doing increasing the doping concentration. If the concentration is decreased, the recombination will decrease and width of depletion layer will decrease.
Decrease.
So that is why you can delete this point. It
Okay.
depends upon the doping concentration. So doping concentration will affect the depletion layer thickness,
Yeah.
and that will indirectly depend upon the Zener breakdown voltage.
Hmm.
More
Yeah.
voltage will be required if thickness will be more. The thickness of the depletion layer will be more. So, so from here you should take these screenshots.
Hmm. Yeah. So from here.
Yeah, actually this point I want to connect with this. So that is why I have taken this point in the last. Otherwise you will not get it.
Okay.
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 So that is why this. After the PN junction diode, na,
Yeah.
this
Yeah.
was the last topic. And after that, this will be the topic.
Okay, sir. Okay.
Yeah.
Done.
Hmm.
Done. Done. Done.
Okay.
Done. 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 Yeah. Done. 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 You're done.
Okay, so after that we will discuss the rectifier, and this rectifier will be the last topic of this chapter. So
Okay, sir.
rectifier, do you know what is rectifier?
Yeah, it's used to measure the.
No, rectifier is used to convert the alternating current into direct current.
Yeah.
And we have to study two types of rectifier: half wave rectifier and full wave rectifier.
Yeah.
So what is the rectifier? This is the rectifier. It is a device used to convert the alternating current to direct current. So alternating current to direct current by rectifier. Two types of rectifier: half wave rectifier, full wave rectifier. The principle of rectifier is that for an ideal diode, the diode will conduct during forward biasing, and it will not conduct during reverse biasing. What I told you in when we were discussing the forward biasing, I told you that in case of the forward biasing, what will happen? The potential barrier will decrease.
Yes.
And current will increase.
Yeah.
Means the diode will be conduct.
It will
Okay.
conduct. Yeah.
It will conduct. Obviously, the current will increase, so it will conduct very well. You can say it will conduct very well. But in case of the reverse biasing, what happened there? In case of the reverse biasing, the potential barrier increased. So due to that, the current is decreased.
Yes.
And the current is due to only minority charge carrier. Okay, so basically for an ideal diode, we can neglect that value of the current. So that is why for an ideal diode, the diode will conduct during forward biasing only. And it will not conduct during the reverse biasing, because we already know that in reverse biasing the current is very, very less.
Yeah.
So for ideal diode, we can consider that the current is zero. Okay. If the diode is not ideal diode, then you cannot say the current in the reverse biasing is zero. It is not zero. It will be very less, but it will be there.
Yes.
But in ideal diode, we can consider the current or in the reverse biasing is zero. So we can say it will not conduct during reverse biasing. So this principle will be used. Now very simple, very simple. Diagram, you should know how to draw the diagram and working and all these things. Okay, I will explain accordingly. So half wave rectifier first. So basically, this is the diagram of the half wave rectifier. This is the basically this is a transformer here. So in transformer, we have seen primary windings are there and secondary windings are there. Okay, so this is the primary winding of the transformer, and this primary winding is connected to AC supply. AC supply means this type of voltage supply will be there.
Okay.
And this is the secondary winding. Okay, and this secondary winding is connected to a diode. This is the diode is connected, and this diode is then connected to the load resistance. RL is the load resistance. Okay. So this figure you have to remember. What is this? There is a transformer. This is the primary coil. Primary winding. Primary winding, and primary winding is connected to AC supply, and secondary winding is connected to diode and load resistance in series. In series, yeah. And this is the output we will get from the load resistance.
Okay.
So what will happen now? In this case, now see, in this case now what will happen? Take this point A and this point as B.
Okay.
This point of the wire, this is the wire now. We connect the devices through wires.
Yes.
Conductors. So point A and point B. So what supply is this? Alternating current supply. Alternating current supply means like this. The potential time graph will be like this. So this is the full cycle from here to here.
Yes.
Full cycle. This is the time 0 and this is the time period T. T is the time period. So from here to here, this is one complete wave or one full cycle, and this time is T by 2. So basically from here to here is half cycle. From here to here is half cycle, and from here to here it is again half cycle.
Half cycle. Yeah.
And from here to here, what you can say, from 0 to t/2 time, it is one half cycle.
Yeah.
From t to t/2 to t time, it is another half cycle.
Yes.
So first we will talk about the positive half cycle. So this is the positive half cycle, means in this the voltage is positive. We are getting the positive voltage.
Yeah.
That is all changing is the other thing, but we are getting the positive voltage. So during the positive half cycle, suppose at any instant, this point of the wire is positive. This has the positive potential, and this B is having the negative potential.
Okay.
Understanding why I am taking the positive polarity.
Yeah. Yeah.
With respect to this, I am taking, okay?
Yeah.
This can be the negative also at any instant of time. I am not saying this end will always be positive, because this is the alternating current. Here alternating voltage is supplied. So due to here mutual induction will take place.
Yes.
What takes place? Here mutual induction will take place.
Yeah.
Mutual induction. In transformer, na mutual induction.
Yeah. Yeah. Yes.
What is the mutual induction? When you will change the current in one coil,
Yeah. In another coil.
and induced EMF will be there in another coil.
Yeah. Induced.
Okay, so mutual induction is there. So here mutual induction is taking place. So due to the mutual induction, here voltage will be produced. So suppose that voltage produced this end of the wire is positive at any instant of time, and this end is negative at any instant of time.
Yeah.
So if this is the positive end, means this is the, you can say, the positive terminal. This will work as a positive terminal of the battery. We can see it as a positive terminal of the battery, and we can see this B end as a negative terminal of the battery. Can we see or not? See, na?
Yeah. Yeah.
Okay. Okay. So now you can see this positive terminal is connected to which side is this? P side.
P side.
And
Yeah.
this is N side.
N side.
Positive terminal is connected to P side. Negative terminal is connected to N side. Means
So
this is a forward biasing.
Yeah. Forward bias.
Forward biasing. And what is the principle of the diode rectifier? We will consider diode as ideal diode. So basically, this diode is the ideal diode. Means this diode will conduct the current. So the current can flow through this diode.
Yeah.
The current can flow through this diode, and after that, after passing the current through the diode, the current can pass through the load resistance, and the current can pass through the load resistance, means we are getting output.
Yeah.
Now, during the negative half cycle, suppose this end is negative.
Yeah.
And this end is positive.
Positive. Yeah.
So this end is negative, means negative end is connected to P side, positive end is connected to N side.
So there was bias.
Reverse bias. So will it conduct? This is the ideal diode again.
No.
This will not conduct, means in this circuit there will be no current, means we will not. There will be no current across the load resistance, and there will be no output.
Yeah.
No theory is written here. During positive working. Now this is the working. That working, just I told you that I have written in words. Nothing is there.
Okay.
So during positive half cycle, suppose end A is positive and end B is negative, and diode is in forward bias, hence current flows across the load resistance, and we will get the output.
Yeah.
Load resistance and output is there. Is obtained, you can write. This is the condition when A is positive. And why here why I am saying A is becoming first positive then negative?
Because it's forward biasing.
No. That is not the reason. Because this is the alternating voltage. From here to here, there is a mutual induction.
Yeah.
And mutual induction is due to the alternating current here. There is the alternating current, na?
Yes, sir.
AC supply is there.
Yeah.
So AC supply is variable. When sometimes it will be positive, sometimes it will be negative.
Yes.
Positive, negative.
Yeah.
So during negative half cycle, and A is negative and B is positive, and diode is reverse bias.
No current.
Reverse bias, and no current will flow through diode, and no output will be obtained. Through diode means, or you can say no current will flow through diode and no current will flow through load and no output will be obtained.
Okay.
So now this is the input diagram, this is the output diagram of the half wave rectifier. So why it is known as the half wave rectifier, you will get to know.
Okay.
This is the complete input you are giving.
Yes.
This is the complete input you are giving.
Yeah.
This is the positive half cycle, negative half cycle, positive half cycle, negative half cycle. So during the positive half cycle only, now we are getting output. During the negative half cycle, this end is becoming negative and this diode is becoming reverse bias, and this diode is not conducting.
Yeah.
So we are not getting the output during
reverse bias.
Reverse bias, or you can say here in the negative half cycle.
Okay.
Due to the positive half cycle, what is happening? This diode is forward bias.
Yeah.
Due to the negative half cycle,
it's reverse bias.
It is better to say when this end will be positive, it will be forward bias.
Okay.
Okay. So input is this, and during the positive half cycle, you are getting the output. During the negative half cycle, means you can write the timing also. This is 0. This is time period by 2. So this is 0. This is t by 2. And again this is t. So 0 to t by 2 positive half cycle, you will get the output. T by 2 to t negative half cycle, no output is there.
No output is there.
Now from t to 3t by 2, from t to 3t by 2, this is t and this is, you can say, 3t by 2. 3t divided by 2. So t to 3t by 2 is positive half cycle. T to 3 by 2 is positive half cycle. Again, you are getting the output. So that is why from the half wave, this is the full wave now. Only half wave is giving the output. That is why this is known as the half wave rectifier. Because half wave is giving the output and other half is not giving the output. So the frequency relation, suppose the frequency of this is f.
Okay.
So can you tell me the frequency of this diagram? Frequency of this wave is f to the frequency of this diagram. Now, what is frequency? Frequency is number of revolution in particular time, or you can say number of revolution in one time period. So in one time period means 0 to 2 time number of revolution also you can say, but here it is in the form of wave. So here you will say number of waves in one time period.
Okay.
So in one time means for 0 to t time, how many waves are there? For 0 to t time, there is only one wave. And
so
here, so just a minute.
Okay.
This is the frequency f. Okay, for this. So what is the frequency? Frequency is number of waves in one time period. One time period means for 0 to t time, how many waves are there? For 0 to t time, there is only one wave. Now check here how many waves are there in 0 to t time. So in 0 to t time, there is only one wave here also. So frequency here also will be f.
Okay.
So frequency of input and output remains same. I told you the reason why the frequency is same, because number of waves in time period is same.
Okay.
After that, we will discuss the full wave rectifier. In full wave rectifier, what we will do? We will connect two diodes. Okay, when one diode will be forward bias, other will be reverse bias. When other will be forward bias,
other will be
reverse bias, and other will be forward bias. So in positive half cycle or in negative half cycle, in both the cases, we will get the output.
Okay, sir.
So full wave rectifier. So this is the full wave rectifier. Again here, primary winding is there, secondary winding is there. This is the transformer. Okay, and primary winding is again connected to the AC input, AC supply. So this
Yes.
type of input you are giving positive half cycle, negative half cycle. So
Yeah.
N1 and N2 here is representing the number of
Number of
turns in
turns.
the
Okay.
winding. Okay,
Okay.
so that is another thing. But here one diode, this is the P side of the diode, this is the N. So this is the one diode and this is the another diode. Here two
Yeah.
diodes are connected, and load resistance is connected like this, hmm,
Okay.
with respect to the winding.
Okay.
Okay, so here to
So it's in
explain
series, right?
what,
The resistance. The resistance.
no, resistance is not in series. We cannot say it is in series. It is in, you can say it is in parallel with
Yeah.
the diode.
Okay. Okay. Yeah.
Hmm. This diode and this diode are in parallel.
Okay.
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 Hmm. Okay. So working is there. So I will only explain the working, and in your words you should write it
Okay.
in exam.
All right.
Okay. So basically the
Okay.
working is again that will be very simple. Uh,
Yeah.
During positive half cycle, suppose this A. Now you understood now why A is getting potential
Yeah.
because of the
Yes.
mutual
Yes.
induction. Mutual induction is taking
Usually.
place. In this coil also there will be the induced EMF, and
Yeah.
induced EMF will be there. Due to the induced EMF, this end gets some positive potential and sometime it will get a negative potential. Why?
Negative.
Because of the alternating voltage.
Yeah. Yes.
Okay. So suppose this end is positive at some time, at a particular time I am saying. This end is negative or positive and this end is negative. So now for this diode, D1 diode, positive is connected with P and negative is connected with N. So this diode is forward wise or reverse wise? Forward wise. So
Or
this
yeah.
diode will conduct the current, means the current can flow through this circuit
Yeah.
or current. But now at the same time, I am saying this end is negative
Yeah.
and this end is positive. So this end is negative means this is connected to P type
Yeah.
and
Pieces.
another end is N type. So this diode is in the
Reverse bias.
reverse bias. So this, though there will be no current
No
in this
current.
circuit,
Yeah. Yes.
in this diode there will be no current. Okay, so leave this diode. So there will be the current only
Yes.
in this circuit, means you will get the current across the load resistance, means you will get the output.
Okay.
Hmm?
Okay.
If there is a current across the load resistance, means you are getting the output.
Okay.
Okay. So okay, now this is positive. Now we will take A is
That's
negative and B is positive. So A
yeah.
is negative and B is positive.
Yeah.
So in this case, negative is connected to P type,
Yes.
uh, and positive is connected to N type. So this is reverse bias.
Yes.
This is reverse bias. And now see this diode. Positive is connected to P, negative is connected to N. So this is
Yeah.
forward bias.
Yeah.
So this time this will not conduct, means there will be no current
No current.
across this through this diode. But this time this is in the negative half cycle. In the negative half cycle, A is
Yeah.
negative and B is positive.
Yeah.
So if A is negative means this is reverse bias, so there will be no current across this, but
Yes.
there will be current across this. This will be conduct
Yeah.
because this is forward bias.
Yes.
Again, the current will flow through this diode and the current can flow like this, and no current will go in this direction. Why?
No.
Because this diode is not conducting. So
Yes.
the current will flow like this. Now
Okay.
this time you will
No
get the
resistance.
current through by this time you will get the current through diode D2.
Yes.
The current will pass through the diode D2 and then it will pass through the resistance, and again you are getting the current across the resistance, mean again you are getting the output, means
Yeah.
during the positive half cycle also you are getting the output, during the negative cycle also you are getting the output.
Yeah.
Shuri, can you write now? When you will
Yes. Yes.
consider during the
Yes.
positive half cycle, A end is negative,
Yeah.
D1 is forward wise and D2 is reverse wise. So D1
Yeah.
will conduct and D2 will not conduct.
Yes.
And through D2 we will get the current through the load, there is load resistance, and we will get the output. During the negative half cycle, D1 is reverse bias and D2 is forward bias. So D2 will conduct, D1 will not conduct, and the current through the resistance will reach through D2. And we will get again the output. Means we are getting the output in positive half cycle and negative half cycle. This theory you can write in your. So now this is the input diagram. So input voltage you are giving in this form.
Yes.
This time period is T/2. And this is 3T/2. Now, can you tell me what will be the frequency? If the frequency of this is F, what will be the frequency of output?
F, right?
I have written also here. Okay, actually, no, I have written, but so you should know the 2F. But you should know the reason. What I told you, what is the frequency? Basically, the frequency is number of waves in one time period or in 1 second. So in 0 to T, how many waves are there? Only one wave. So the frequency is F. But here in 0 to T time period, how many waves are there? 2 waves are there. So the frequency will become double.
Okay.
So frequency of the output will become double of input.
Okay.
Working, you can write here. After that, now you can see this graph. What is the work of the rectifier? To convert the alternating current into a direct current.
DC. Yeah.
Sorry.
Yeah.
But you can see this graph. This is the DC current, but this is a pulsating DC current. In this DC current, there is some component of AC also. Some characteristics of alternating current is there in this. So what we will do, we want the pure DC. And what is pure DC? Pure DC is like this. Straight line. This type.
Yes.
Not pulsating. This is the pure DC.
Pure DC.
So to get the pure DC, what we will do? In this, there is some component of AC also. So we will filter that AC component. And to filter that AC component, we will use the filter circuit. So next topic is the filter circuit.
Okay, sir.
So now filter circuit, the output obtained from the rectifier is unidirectional, but pulsating. Unidirectional means positive output only you are getting this positive.
Yeah.
Plus, 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 unidirectional. But this is pulsating.
Yes.
The output obtained from the pulsating. What is the meaning of the pulsating? How we can say this is pulsating? Why? Because now you can see from here to here, the value of the voltage is changing. First, this is increasing. From here to here, it is increasing. Then it is decreasing. Then it is in the form of pulse like this.
Okay. Yeah.
Pulse means something is increasing and decreasing, and then again decreasing, then again.
Yeah. Okay, sir.
So to the output obtained from the rectifier is unidirectional but pulsating. To get the pure DC, filter circuits are used. So we will discuss the filter circuit, and there is a filter circuit known as the shunt capacitor filter. Shunt capacitor filter. So shunt capacitor filter is what? This is the full wave rectifier. In this full wave rectifier, what we will do? We will connect a capacitor in parallel with the load resistance.
Yeah.
We will connect a capacitor in parallel with the load resistance. Yes. So what will happen? The current will go, the current, or this is the output current that is going across the resistance, and this current is containing This current is containing DC. DC current is there, but some of the component of AC is also there.
Okay.
So we have to somehow remove this AC component.
Okay.
Okay, Azan time, I think. No. Okay. So it is DC and it is AC. Some component of AC is also there. So what will happen now? Now Azan time. Okay, we will wait for 1 minute.
Okay.
Okay. So this you have connected the capacitor in parallel with the load resistance. So now this current is coming towards the load resistance.
Yeah.
So one thing you know, in case of the capacitor, in case of the capacitor, no DC current can flow. DC current cannot flow in capacitor. In capacitor only AC current can flow because for DC the frequency of DC current is 0.
Yeah.
Angular frequency or
Yeah.
frequency is 0. So the capacitive reactance that will be equal to XC. It will be 1 upon omega C, and this will become infinite. Means capacitive reactance will be infinite. That is why capacitive reactance become infinite for the current. That is why the current cannot flow through the capacitor, or capacitor blocks DC. So all the AC current will flow through the capacitor, or you can say all the DC current will go through the, because DC current cannot flow through the capacitor. So
Yeah.
all the DC current will go through the load resistance.
Yeah.
And all the DC, oh sorry, what I am doing. All the DC current will go across load
Yeah.
and all AC will go to the capacitor.
Yeah.
So now what current is going in the load resistance? The current that is going in the load resistance is DC current, and
Yeah.
the current which is going in the load resistance is the output. So now we will get the purely DC output. So this
Okay.
type of output we will get.
Okay. Okay.
So this is the theory to filter AC current component from the output obtained by rectifier. We need to convert a we need to connect a capacitor in parallel with the load resistance, and capacitor offer infinite resistance to DC, and pure DC will flow across load resistance.
Okay.
So you can take the screenshot from.
Yes, sir. Done. 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 Yeah, done. Done. Yeah, done.
Okay.
Done. Done. Yeah, done.
Okay. So this chapter is also finished. Okay. This was the
Okay.
last chapter, and so this time from this chapter at least 30 to 40% syllabus is reduced.
Okay.
Hmm. Okay, so when will be your physics exam on?
So boards, right?
Hmm.
I'll have to check. So.
I think it will be in March.
Uh, yeah, sir.
Hmm.
March 6th, sir.
Hmm. So are you revising previous chapters?
I'm not getting the time actually, sir, because my pre-boards are going on right now.
Yeah. Okay. Okay. So
Yeah.
okay. So basically your pre-boards are going na.
Yeah.
During that also you are doing something na. Means
Yeah.
you are
Yeah.
revising the
Yeah,
notes.
sir. Yeah.
Means you are preparing for that is also a type of revision.
Yeah, sir.
And how the pre-boards are going?
It's going nicely, sir. It's nice.
So now I want to tell you one thing. Basically, after that, maybe you will not join the next class because you have exam. So when you will attempt the exam or attempt any question,
Yeah.
so don't hurry up. First, read the question. What the question is saying.
Yes, sir.
Hmm?
Yeah.
Directly, don't apply any formula. Hmm?
Okay.
Don't be in hurry. Read the question properly. See what the data is given, and then try to think. After that, try to think, and after that, the formula, the concept, and apply there. This is the one of the factor.
Okay.
And you should have the previous year question of this exam. Have you?
The sample papers, right?
Yeah, sample papers type. So now, what you should do from there also,
Yeah.
you should solve some of the question from each chapters.
Okay.
From electrostatic to semiconductor,
Okay.
and try uh, your derivation skills.
Yeah.
Derivation skills means how to drive any relation, three types of things are there: derivation, theoretical concepts, and numericals.
Yes.
Theoretical concepts are, to understand that is not that hard, but to solve the numericals or to solve the or to do the derivation, there is a requirement of little basic maths.
Yes.
Sometimes it is integration, sometimes it is differentiation, sometimes it is geometry.
Yeah.
So try to focus on that.
Okay.
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 For example, mostly integration we have to do in electrostatics. Electrostatics, electrodynamics, we have to do integration most of the time. In case of the modern physics, there is no, the modern physics is simple, I will say. That is very scoring also. So what is the meaning of the modern physics? I told you the modern physics from atoms to the atoms and nuclei.
Yeah.
This is the modern physics, basically.
Yeah.
Semiconductor is the also, I will say, a modern physics, but it is a part of the electronics engineering, electronics and communication.
Yes.
So that is another thing. But I want to say that uh, those chapters are quite easy as compared to the electrostatics and magnetic effect of current, uh, and after that there is a part that is optics. So basically in optics, na, optics, the how you should approach for optics. When you are doing optics, na, so revise the optics by drawing the diagram.
Yeah. Yes.
Hmm? Any formula or any expression, you should relate with the phenomena what is happening there. Directly, you should not learn anything. If I am saying 1 upon f is equal to 1 upon v minus 1 upon f is equal to 1 upon v plus 1 upon v. So you should have in your mind what is this formula, and this is for mirror and this is for lens, and how the lens look like and how the mirrors look like. And lenses are also two types: convex lens, concave lens. Hmm. So that way is different. Okay, so try to revise properly, and if you want any type of guidance and any type of help, then I am available all the time. Okay, you can contact me. I think you have my number also. If you are getting any problem in anything regarding the exams, not for this subject, for any other subject, means I can guide for other subject also. Okay, physics or math. And if you are facing any type of problem, means if you are not getting the derivations, means how to do that.
Yes.
The thing is that you can contact me, or I am giving one simple tip. First, whenever any derivation is there, suppose I am saying that derive the potential energy of two charge system, from the electrostatic, if I am saying that.
Okay.
So you should understand first what is the potential energy. Understand means you should try to think in your mind what is the potential energy, and try to think then how can relate the potential energy, and what is the potential energy. Potential energy is related to something which is related to work, and this is only be done by doing by on copy. There is no other way.
Yes, sir.
We already did these types of things.
Yes, sir.
So you can either use these notes. If these notes are useful for you, then you can use these notes also. We have covered. I tried to cover all these things. Okay, in the time we have, because we have a less time, because in week we were getting only 3 hours.
Yes.
And that is, I think, not enough.
Yes.
Due to your timing, that is done, but I think there should be more time. But no, don't worry. We actually have finished all the main things, but two things we have not completed. That is wave optics, and there is one natural magnetism and material and magnetism. I think that chapter. So I think I am hoping that you did that in your school. So
we did.
you can revise that. Okay.
Okay, sir.
So okay, and focus on the thing which you already knew very well.
Okay, sir.
More focus on the things you know very well. Revise those things again and again.
Okay, sir.
Okay, and for example, suppose in the exam, the question is that, like, what is the astronomical telescope? So
Yes.
for that, you have to do the diagram practice of the, you should do the diagram practice also.
Yes, sir.
Diagram, no? How to draw the diagram.
Yeah. Yes.
And once you have drawn the diagram, working, I know you can write
Working
razor
is
coming
easy.
from
Yeah.
infinity and all that. In your
Yeah.
language, you can write.
Yeah.
Okay. But here there is one more point. In your board exam, na, you
Yeah.
will not get very difficult question. You will get easy question, but there will be some tricky type of question. Okay. For example, they can ask you why capacitor blocks DC. They can ask you why the capacitor can block DC. They can ask.
Okay.
So in that, I have not written this anywhere, I think, if I have not written, but in one or other chapter, somewhere I told you.
Yeah.
For example, I told you this here. Maybe I not told you in the alternating current when we were discussing. Okay.
Yes, sir.
And suppose they are asking why the heavier nuclei do the fission and lighter nuclei do the uh, fusion.
Yeah.
So you have to apply your mind. I told you the whole concept of fission and fusion because lighter nuclei is having low uh, uh, binding energy per nucleon.
Yes.
To achieve the stability, the binding energy per nucleon should be more.
Yes.
So for that, those nuclei, according to the graph, there is a graph na, like this. First increase, then decrease.
Yes, sir. Yes.
So heavier nuclei is, you can take the example of uranium-238. So that is breaking into krypton and barium. So basically, there you can say that I'm just explaining means how the question will arise and how you have to apply your mind. And from the notes and from the theory that I told you, you have to just abstract that so
Yes,
that
sir.
you can solve that question. So you can say that heavier nuclei to get the stability, they break into the lighter nuclei, and those lighter nuclei will have the uh, more binding energy per nucleon as compared to the previous nuclei. And the lighter nuclei do the fusion reaction. Why? Because after combining, they are getting the nuclei which is having the more energy, binding energy per nucleon. So basically, it is a game of binding energy per nucleon. The stability of nuclei, I told you, is depending upon not on the binding energy, it is depending upon the binding energy per nucleon. So this is just the example. You will get uh, hundreds of questions on different topics. Okay. So accordingly, you have to deal with in a proper manner. Read the question first. Okay. And will you join tomorrow's class?
I will see, sir. I will let you know.
Okay, it's fine. Okay. So
I
do
think
your
I'll be able to
revision.
join, sir. I think I think I can join. Yeah.
If you will join, then in that class we can revise some of the topics.
Yeah.
Okay.
Okay, sir. Okay.
We can revise from the topics electrostatics and all that. We will once recap we can do. If you can join, it is better. Otherwise, no problem. You can go with your time and